Hansen Theory. Episode 01. Why did traditional solubility models fail and give birth to Hansen Theory? Welcome to Hansen Theory. You're not here to memorize chemistry. You are here to understand how real coatings behave in the real world. Pause for a moment and think. For decades, engineers trusted a simple idea. If two materials share a similar solubility number, they should dissolve. One number, one decision, one shortcut. It looked scientific. It looked clean. It looked efficient. But production floors told a different story. Resins that should dissolve didn't. Clear coats that should stay transparent turned hazy. Pigments that should stay dispersed flocculated. Solvent blends that should work failed during scale-up. And the most dangerous part? Engineers blamed raw materials. They blamed suppliers. They blamed processing. Very few asked the real question. What if solubility is not controlled by one force? What if molecular interactions are more complex than a single number can represent? This question is where Hansen theory begins. Early solubility models treated materials as if they were simple liquids with uniform behavior. But coatings are not simple liquids. A coating formulation is a complex molecular system. You're working with long polymer chains. You're working with polar functional groups. You are working with hydrogen bonding sites. You are working with dispersants, wetting agents, pigments, fillers, and solvent blends. All of these interact at the molecular level. All of these respond differently to different types of forces. Yet engineers tried to force this complexity into one parameter. That approach was comfortable. But comfort never produces progress. Charles Hansen did not try to improve the old model. He challenged the foundation itself. Instead of asking whether something dissolves, he asked a deeper question. What type of molecular forces are responsible for compatibility? This was a fundamental shift. He recognized that solubility is not a single phenomenon. It is the combined effect of multiple interaction mechanisms happening simultaneously. Dispersion forces, polar forces, hydrogen bonding forces. Each one contributes differently depending on the chemistry of the resin, solvent, or additive. When these forces align properly, compatibility occurs. When they do not, failure occurs. This is why coatings that look fine in small lab trials sometimes fail in production. Because small-scale success does not always reveal molecular mismatches. Hansen theory introduced structure into this chaos. Instead of using one number, Hansen created a three-dimensional interaction framework. Not to make things complicated, but to make reality visible. This is what most engineers misunderstand. Hansen theory is not a formula. It is not a software tool. It is not a spreadsheet calculation. It is a way of thinking about molecular behavior. When you understand this, your formulation decisions change. You stop randomly testing solvents. You stop blindly trusting datasheets. You stop trial and error experimentation without direction. You start predicting behavior. You start designing compatibility. You start engineering outcomes. But here is the uncomfortable truth. Most engineers today use Hansen theory incorrectly. They plug numbers into calculators. They generate plots. They look at distance values. But they do not understand what those numbers physically represent. They treat Hansen theory as a black box. And black box thinking always creates dependency. Dependency on software. Dependency on suppliers. Dependency on trial batches. This masterclass exists to break that dependency. Because the industry does not need more operators. It needs thinkers. It needs engineers who understand why things work, not just how to follow procedures. In this series, you will not be trained to memorize parameters. You will be trained to see coatings as molecular systems. You will learn why dispersion forces dominate hydrocarbon systems. Why polar forces influence adhesion and compatibility. Why hydrogen bonding controls stability and wetting behavior. You will learn how Hansen space represents chemical reality, not just mathematical geometry. You will learn how experienced formulators use this theory to design solvent blends, improve dispersion, and troubleshoot failures. And most importantly, you will learn where Hansen theory does not work. Because real engineering mastery is not about believing in tools blindly. It is about understanding their limits. This is what separates average engineers from minority engineers. Average engineers follow instructions. Minority engineers understand systems. Average engineers react to problems. Minority engineers predict them. If you are here only for formulas, this series will feel slow. If you are here to build formulation intelligence, this series will change how you work forever. In the next episode, we will break down the 3 molecular forces behind Hansen theory. Not as symbols, not as textbook definitions, but as physical interactions happening inside your coding system every second. If you are ready to stop guessing and start engineering, stay with the series. This is Hansen Theory.